Hey everybody, this is Mr. Lava back here with some more Algebra 1 CP final exam review. In this video, we're going to talk about some of the major types of word problems that we covered throughout the semester here. So the first being proportions, okay, and how we set those up. If you remember what a proportion is two fractions or two ratios that are set equal to each other. So when I read this question, I'll show you a couple of ways to set this up. I'll show you one way to set this up. It's not actually the only way. So um, if your teacher taught you a different way, you could definitely go about that. There's more than one right way to get the right answer here. All right, so a cell phone company found that 15 of their phones sold in June were defective. The company sold 250 phones in June. Okay, so right when I read this, I notice that there's 15 phones that are defective. All right, and then it tells me that they sold a total of 250 phones. All right, and we're talking about the same month here. We're talking about June. Okay, and then I go on to read how many of the 300 phones sold in July. So there's 300 phones sold, and they're again sold in July. What I expect to be defective. All right, so the way I want to set this up, and again, this isn't the only way, but it's a pretty easy way to do this. I want to set this up, and what I'm going to do is I'm going to label this before I plug anything in. So what I'm looking at here, if I look at everything I've highlighted in red, all right, I have 15 defective phones in June. So defective June, all right? And then down below it, I have the total sold in June. Okay, and then I go to the next fraction here. This talks about July. So I'm going to set this up the same way I set up the first one, but the difference is that the month is going to change. So this is the total in July. All right, now when I go to do this, when I go to solve this, it's important that you do this step so when you plug your numbers in, it's fairly straightforward. Now I want you to notice something here. On the top of this fraction, I have defective phones. Well, I want to match that same label in the other fraction, so I have defective on top. And since I put the total on bottom here, I put the total in the other month over here. Just make sure those labels match up and you'll be fine. Okay, so in June, the amount of defective phones, there's 15 of them, and we sold 250 phones in June. And then in July, I don't know how many defective there were, so I'm going to put X there because that's what we're trying to find. But I know I sold 300 phones, or we're expecting to sell 300 phones. So there's your setup. Now to solve these, it's actually fairly straightforward. You're going to cross multiply. And please, 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 please use your calculator for this so you don't make any mistakes. All right, so the way I cross multiply, I'm going to go 15 times 300. And that gives you 4,500. So again, cross multiply, you just take the top one here times the bottom one here. All right, so 4,500 equals 250 times x is 250x. Okay, now it's a straightforward solve problem. So if you need to, draw your line in the middle of the equal sign and get the variable by itself. So get the letter alone. Well, the letter this time is on the right side of that equal sign or the right side of the line. So the number that needs to move away from it's the 250. The 250 is attached, so divide by 250. Okay, and then x equals 4,500 divided by 250. And that comes out to 18. And 18 what? This was 18 phones. And defective phones if you want to get technical here, but make sure you label your answer. All right, so that's proportions. Okay, moving on. We went from proportions to basic percent problems. All right, when we start talking about percent problems, just read it and translate it. So we had saw that on the first page of your review sheet, so there it is. What number, well, what number x is means equal 25%. The way we change a percent for use in calculations is we write it over 100 or divide it by 100, which shifts the decimal points 2 places to the left. So 25% of means multiply, so of 80. And then again, I want to get rid of all my parentheses, just like we always do. So 0.25 times 80 gives you 20. And then you want to get the variable by itself. You want to solve for it. So if I solve for x, there's no work to do because x is already by itself. So that's my answer, 20. Okay, 20. All right, the next one. 36 inches, so 36 inches is means equal. 43%, again, take 43 divided by 100 to get the decimal value. Of means multiply. What length? Well, we don't know the length, so I'm going to call it x. All right, so this one, there's actually a little bit more work to do. No parentheses or anything, but there's a little more work to do. I got to get x by itself. X is on the right, so I'm going to move that 0.43. It's attached to the x, so I'm going to divide by it. 0.43 divided by 0.43. On this side, you get 36 divided by 0.43. 83.7, all right, pretty close to that, equals x. Okay, so there we go. That's my answer. All right, and if you notice, I'm taking some time in between the calculations because I'm actually using my calculator. You can't see me using it, but I'm using my calculator here to do all these. So, you know, if it's important enough for me to use my calculator, students, you need to do the same. Okay, slope-intercept problem. These are pretty straightforward. All right. The one thing you want to look out for is you want to try to figure out what your independent and what your dependent variables are, and then you're going to write in the equation. Now, you already studied slope-intercept form. You didn't study it before when you actually learned these during the school year, but you studied it as part of graphing. So you guys know that slope-intercept form looks like this: y equals mx plus b. All right. And you know that m is slope, while another code name for slope is rate. So when you see a rate in your problem, right, that's what you want to attach the x to. And then b is your y-intercept, which when you graph, that's where you begin at. So I'm going to call this the beginning amount. So when I go to set up my problem, it's actually pretty easy to do. All right, so here it is. Joe has $25 in his savings account. Little hint here. Normally when we talk about money, money is usually your dependent variable, so it's usually your y. All right, so Joe has $25 in his savings account. He plans on spending $5 per week. So here you go, the $5 per week, there's your rate. That would be your slope. All right, he has $25 in his account. Okay, so that's his starting amount, or his B, his beginning amount. So the way I actually like to set these up is I do it this way, a little different than some of the other teachers do, but it's the same thing. I always put the starting amount first. It just seems to me to make sense to put what you're starting with first. And then how does that starting amount change? Well, if he's spending $5 per week, he's losing $5 per week. So again, the 5 is your rate, which is your slope. We know that slope gets attached to the x. All right, so that's how I set it up. And then when I actually write the answer, so it asks me for write the equation. Well, when I write the equation, I actually flip it around so it matches correctly. You want the x written first. Just be careful of your signs when you do this, and then plus 25. Okay, so there's my equation. And now the question they ask me is they want to know, how long will it take for Joe not to have any money? Well, if Joe's not going to have any money, look at what you did here. The x is the number of weeks. The y is the amount of money. So we want to know, when is he going to have $0, no money? All right, equal to 5x plus 25. And you could probably figure this out without writing the equation or solving, but it's good practice. This is a pretty simple example, just so you can understand this as you're reading this on your own here. Oh, probably want to put my line here just to help those of you who have trouble solving. So let's just get x by itself, because x is weeks. Well, weeks is a time, and they want to know how long. So negative 25 equals negative 5x. I'm going to divide by negative 5, divide by negative 5. You get x equals 5, positive 5. All right, now be careful on these. If they're word problems, don't leave the numbers naked. What I mean by that is just don't write it as a number. Make sure you put a label on it. So our answer here would be 5 weeks. Okay, and again, this is a pretty easy example. Just make sure you're watching it and you're paying attention to what you're doing, because this applies to a lot of what first semester Algebra 1 is. I believe on the first page of your review packet, there is a word problem on here that is a slope-intercept problem. So you can take a look at that and reference this video to help. All right, have a good day.